So now we're going to talk about the building envelope. Why you need to learn building terms. It's important when you liaise with tradespersons like electricians and builders and plumbers, you can convey your concerns about a site and provide accurate advice. If you don't know what a noggin is, or a bearer, or a rafter, or whatever, you can often be quite embarrassed because they're going on about buildings and about rafters and all these different parts of the building, and you don't even know what part they're talking about. And here you are specifying in terms of what materials to use in the building or design. It's really important that you know these terms that are used in like builders. Provide advice to building designers and how to build a healthy home. Obviously, as building designers, they're going to know all the building terms. Give the client confidence that you know what you're talking about. I think these are all pretty obvious. We're not going to go through all of them because I'm not here to just talk about what's in the manual. I'm here to give you other advice. More practical, you can read the manual anytime. But for example, architrave, the molding and fixing is a surrounding to a door or window opening. So just that bit that goes around the doors, that trim, that's what they call an architrave. So anything around doors and windows, they call the architraves. Or it's usually timber or MDF or whatever, just frames it, basically. A bearer is a subfloor timber supporting the floor joists. So you'll have a bearer going one way in your floor, and then you'll have the joists going the other way. And then that's what they lay the timber floorboards on and so on. And we've got drawings in the next few, or diagrams in the next few slides, so you'll see what that means. Cladding's any material used to cover the frame. So when you put the building frame up, whatever you clad it on the outside, usually cladding is referred to as the weatherboards is a typical cladding, but basically it's anything that you put onto the outside framing. Could be stone, could be anything. On the wall or the roof, such as brick, weatherboards, corrugated iron. A cornice is a molding used as a finish between the ceiling and the wall. So the cornice, that stands to reason. You've got the ceiling and you've got the wall right up at the top, and that's what finishes the cornice, is the bit that goes around and joins the two. Efflorescence is a powdery deposit of soluble salts on the surface of a wall, washed out by rain from the bricks or mortar between bricks. Efflorescence, actually a lot of builders might not know what that is. I've spoken to a lot of people who don't know what, a bit of a strange word, efflorescence. You sound very educated when you say it. But basically it is just salts that are coming out usually because there's too much water there. I've been asked to sample that. People think it's mold because some molds when they're white look like that. But really you seldom find mold where there's efflorescence because it's that salty. But it means that there's a problem and there could be mold somewhere else because there's a lot of moisture, too much moisture. There should not be efflorescence and salts coming out. There's too much moisture somewhere. But yes, you'll often see that powdery white stuff. It's just salt. Flashing pieces of galvanized iron, lead or other impervious material to prevent the penetration of moisture. Flashing you'll see just below the gutters. You'll see what they call flashing. It just wraps around everywhere. It's usually the piece that rots around corners of gutters. When you get to a corner, you often find the gutters, it will often get blocked where there's a join in the corner. And sometimes water can leak back into the fascia boards, and you'll find that the corner fascia boards are sometimes rotten. You can push your finger through it in older homes. But we'll see on the diagrams, you'll see what we mean. Joists are the parallel timber laid on the edge from wall to wall, which the floor or ceiling's fixed to. Easier to know in a diagram. Noggin is an intermediate trimming between structural members of a timber frame. You won't know what that means when you read that, but when we show you on the diagrams, you basically got your studs in the wall, and a noggin is just basically a piece of timber that goes that way to brace it, and then you'll get another stud there. That's all it is. Pergola, a roof structure over a patio created by beams and rafters. I think just about everyone knows what a pergola is. Sarking, additional waterproofing using building paper under tiles or corrugated iron to control condensation. Sarking, a lot of people often don't know what sarking means, what sarking is. Not builders, but often people that you'll deal with who have come to you to help specify. And sarking it's almost like a foil wrap for the ceiling, basically. Extremely important when it comes to metal ColourBond roofs, which are very, very popular. I've gone to many homes that are older where they did not used to put sarking under the ColourBond roof. So what happens is when that metal gets very, very hot during the day and then it gets very cold at night, it will condensate, and all those little drips on the underside of that roof will drip down. If you don't have any insulation bats on the ceiling, it will drip down and just land on your ceiling, or it will drip into your insulation. That's why I mentioned polyester bats, because they won't support that growth. But literally, I've had homes where people have been debilitated and they literally need to pull the ColourBond, pieces of the ColourBond roof back, and then put down the sarking or this wrap, and then put the roof back on again. Because if you don't do that, condensation is just going to be an issue. And condensation is an issue when it comes to metal. Whether you've got light or dark colours, yes, light colours are better, it's still metal. It's still going to have a big temperature difference and cause condensation and cause mold issues. I've seen it many, many, many times. Now they always put sarking under the metal roofs. Skirting board, the liner board protecting the interior wall that makes contact with the floor. It's decorative, but for builders it's also there to cover up where things don't really evenly match. You know you have an immaculate, proud builder when there are no skirting boards, and you can see how beautifully straight and aligned everything is with the floor and the wall. Most builders dare not leave out a skirting board because you will see many gaps and cracks and movement, whatever. So it also does finish it off nicely, it does look nice. But yes, on the floor where the wall meets the floor, that piece, that's what's called a skirting board. Can hide a lot of imperfections. Stud, a vertical structural unit in timber or steel framing. You know, they often get the stud finders. They say when you hang pictures, you must try going to a stud. It's basically that part of the frame that is upright. So the building envelope is the physical separator between the interior and exterior of a building. All right, that's the envelope. That's what protects you from the elements. It's going to protect you from the rain, the dust, all of that type of thing. In fact, on sarking, on the subject of sarking, not only is it used for condensation, but also insulation. What's really important is it keeps all the debris out. When I go into a roof space, look into a roof space where there's no sarking, you just need a couple of little roof leaks or a bit of water in there. There's debris everywhere, soil and leaves and all sorts of things that blow in just under the tiles, between the tiles or the ColourBond roof and the gutter, and you get all of this blowing into the roof space, tons of debris, and you just need a little bit of moisture or condensation and you've got a mold problem. So with sarking, it also helps to keep the roof cavity nice and clean. So yes, this is what we're talking about in terms of the envelope. So it consists of a floor that goes on the ground level, the walls which protect you on all sides, and then the roof. And then the windows, doors and skylights also, you can cut holes into that envelope and you get windows, doors and skylights. So I think that's self-explanatory. The best way to see the various layers that make up the building envelope, floors, walls and roof, is to visit the access point, or what's generally called the manhole in the subfloor. So where you access the subfloor and you look in under there, if it has a subfloor, it's not on a slab, then you can often just look next to the door and you'll be able to see, oh right, so it's a timber frame, there's no wrap, or there's this wrap over there, there's no insulation bats, or there is. You can see exactly. And what's really important in terms of that envelope, there are many things important, but if I can say this, and if you only get one thing out of the building envelope, let it be this, please, is that if you, again, just put air gaps, small air gaps between everything, that the architect, designer, the builder, whoever's done your plans, allows for a big enough wall cavity so that you can have the frame, you can fit in your bulk insulation by not pushing it in at all, because that will compromise the insulation, take all the air gaps out of it. So they need to allow enough space where you go, I want to fit an R3 bat in the wall. They know exactly how wide that R3 bat is, they know how wide the frame is, and they say, what are you going to use? Internal plasterboard? You're going to use brick here? They need to allow that you can just put in that insulation batt, and that it doesn't touch the wrap. So part of the envelope will be a wrap which protects you from the wind-driven rain and so on. You've got to have that, and you don't want your insulation touching that, because that's what can compromise things too. If you just have a little air gap, if you just have them basically apart from one another, you will again just improve things so much. And all it is a tiny detail on the drawings to ensure that that is done. So you can have a look there in the manhole. A display village where homes are at various stages of construction. That's always interesting. Walking around homes being constructed, you can see very easily how homes are put together, especially in the wall and the envelope. Your local hardware store sometimes has displays. Anyway, here are the diagrams. This is the timber wall frame. So you can see here that this is a pier, a brick pier. So this is not on stumps, it's called piers. So this one's out of brick, or you can have what used to be timber stumps, and they rotted very easily and so on. Now they use concrete stumps all the time. And usually if there's an ant capping, it's on top of that pier to stop the ants from try and stop the ants from getting to the timber. And then we've got, basically you've got a bearer. This is the bearer, that piece that runs all there. So you know that the bearer will go onto the pier and run across like that. And then you've got the floor joists. So the joists are these ones going across. So that's all people are talking about. Those are the terms you just need to know. That they're putting bearers down and they're putting joists down. Basically, it's the timber frame of your floor. That's all. And it's got two different names for timber going two different ways. That's all it is. There's nothing more than that. But these are the terms that are used, and important for you to know that. There's a window head batten. It just means the timber or whatever is being used at the top of the window. So it's just nice so that you can see basically what we're talking about in context. The next diagram, a brick veneer frame. So here we have what I was trying to explain about a noggin. So in the wall here you have your stud, which is what you're always trying to get into. What's really important and is overlooked all the time, but you know you've got a great builder, is when you position the studs, when you're going to put in a bathroom, for example, they make sure that where you're going to put your toilet roll holder and your towel rails, that they actually put studs closer together in those specific areas. They'll put in an extra stud or say, right, here are the studs, and this is how you want your towel rail or your toilet holder. They're always coming out the wall, irritating you, trying to find how best to stick it in the plasterboard. But good builders will look at that, and they'll make sure that there's a stud here, and if your toilet is here, your toilet roll holder is going to go straight into that stud. So that's a stud, and that's the noggin. Again, it's just stud and noggins are just two different terms for your timber frame that are going in two different directions. That's all, same as the bearers and the joists for the floor. And that's it. A couple of other terms, stud, bearer. And here you can see where you've got the brick on the outside, then you've got the timber frame, and then you've got the plasterboard on the inside. So here the brick is the cladding. So whatever's going on the outside of the framework is your cladding, and whatever's on the inside is on the inside. That's your internal wall. So yeah, the vapor barrier, basically they would put in the insulation batts over here where there's space, and that's why we spoke about just before, making sure you've got enough space, and then you'll have the wrap there. So that wrap needs to not touch and go up against the insulation ideally, and that's all just making sure that you have a deep enough wall cavity, which is just a small detail that makes such an enormous difference. So these small things are placing studs where you want to put things in the wall and leaving little air gaps so that you can fit all your insulation and your wrap in. So your wall will have your cladding, your frame, it'll have your wrap, it'll have your bulk insulation, and then your internal wall. And that's basically your wall envelope, so to speak. So it doesn't sound very complex, and it's not that complex, but that's where everything can go very wrong. For example, in New Zealand, they've had major issues where they put, and we do it here a lot in Australia as well, where we put impermeable vapor membranes there. So that wrap that goes around in the wall is impermeable. So it said, well, we're stopping the rain. You know, we want to stop the rain, not get it in. But what happens is when condensation takes place, it hits that wrap that's impermeable, it condensates, and you get all sorts of mold issues inside this cavity, in your insulation and your wrap, and you won't pick it up unless it's dramatic. Condensation issues you won't pick up by taking moisture readings on this, because we're inside. We take moisture readings on this internal wall here. We take moisture readings on that brick on the outside, but it's condensating right in the middle. It's gone through the brick, it's hit the vapor membrane, and it's condensated. And we can't pick that up. So we take moisture readings in the air, both inside, to see if that's an issue, but sometimes that's the thing that can be easily missed. And it often only comes about in winter. You'll go there in summer and think everything's fine. Come winter, things start turning black. And it's just because there is so much moisture in that wall cavity because the envelope is wrong. It also often happens in a window where the flashing is compromised, or where you put your window, it is not watertight. That's again where there's condensation, or when actual wind-driven rain gets in there. You want to protect this cavity by all means and cost, for insulation purposes and condensation purposes. And the wrap needs to be vapor permeable. No impermeable wraps. That wrap needs to be vapor permeable, and it needs to be such that it takes into account the diffusion rate of all those materials. So brick, for example, the diffusion rate of that, the insulation batt, the diffusion rate of that, and plasterboard, whatever you're using inside, the diffusion rate. And it will basically then look at the climate and say, right, are you always having the aircon on because it's always hot? So it's going to be cold air from the inside and much warmer outside. Or is it the opposite? In Melbourne, it's always more cold than it is warm, even though we get the stinking days, but we have colder weather more than warmer weather. So more often, it's colder outside and we got heating inside and warmer inside. That makes a difference on your vapor barrier. There are different vapor barriers to allow diffusion from different sides at different rates. So it's not just a matter, you will find there are some vapor membranes on the market that are just permeable vapor membranes. So just a wrap with holes in it. And that does work better than an impermeable, but I listened to a talk at a green building conference from a big supplier of these wraps, and they supply a permeable wrap, and they said they're supplying it because there are big issues with the impermeable, but even their permeable wrap's not quite good enough. So it's why we recommend, and you'll see later on, ProClima, the Intello wrap. Guys in New Zealand do what I think is the best wrap on the market. And you can literally tell them what your building envelope is, what the external cladding is, what insulation you're using, what the internal cladding is, what your weather's like if you heat or cool more, and they will specify this is the wrap you need. And that is the way to go. Double brick wall frame. So in South Africa, where I'm originally from, labour is much cheaper. We have a lot of double bricked homes. Here, where we need to do it a lot quicker, there's a lot of timber frames and cladding. So here we have the double brick. So there will be a cavity between the double brick, and you have external brick and you have an internal brick. So you don't usually put insulation in between here, but you've got this double brick layer, and there's some brick cavity ties where you can just tie this and keep it together. In terms of your envelope, also if you have a subfloor space, then you'll find these grills for ventilation. They are very important, ventilation obviously under the floor. As soon as you have a subfloor and you're not on a slab on the ground, you have to be very mindful of subfloor spaces. They are a real problem. We had Americans come over, indoor air quality specialists, and they were quite amazed at our subfloors and said, my goodness, it's such a big problem here, subfloors. Often because it's just dirt. So you'll get winds that come through there, blows up the dirt. You have a lot of problems with things being so dusty all the time, and it's just because there's all that soil under there and you've got ventilation coming up. If you are going to have a subfloor space of any kind, in my opinion, you must have very good subfloor ventilation and insulation. So you don't often see insulation. You'll see the vents for ventilation, but you won't often see insulation. In my opinion, you should have insulation, where if this is your top floorboard, you put another subfloor right under it, and you put an insulation batt in the middle there. So the air has to get through the plywood, the whatever timber you use, then it needs to get through the insulation batt, then it needs to get through an air gap, then it needs to get through the floorboard. So if it makes it, you give it a bottle of champagne and say, well done, you got in. Because that's what will insulate you really well. But if you get a dusty, non-insulated, you just got floorboard and dust and vents, it's a disaster. Especially if these bricks are very porous. There are many different kinds of bricks, and some are a lot more porous than others. And you need to check how porous the bricks are. So all the bricks will have that ability to be hygroscopic. During rains they'll absorb and you'll get high readings, then they'll release it. But there are some bricks that are so porous they just wet all the time, and that's not what you want. So you want to be able to cope with it, but not be wet all the time. So this is a double, so this is the double brick configuration, which I think in Perth they do more double brick. So weatherboard clad frame. So now when you've got a weatherboard, this is where you will put a cladding on the outside. So there's your stud walling, a top plate. So a rafter is just timber in the ceiling that's going up at that angle. That's what a rafter is. So they give a different name for every piece of timber of the frame that's going in a particular direction. And that's all you just need to familiarize yourself with. That's all. There's nothing fancier than that. So this is the roof sheeting, be it Colorbond or whatever it is. This is the gutter, and this is the fascia. So the fascia is usually that piece of timber that lies just in front of the gutters over there. And that's why I say that's usually what rots on the corners here. Look at the fascia boards on the corners, and you'll often see in gutters, that's where if anything's going to collect, it collects in that corner, and then the water can't move and starts rotting the fascia board. So when you go to a house to inspect, just have a look at the corners and the fascia boards. You can immediately get an idea of whether there's been some water issues. And then the cladding here is just the weatherboards. So these are splayed weatherboards put on, and they put a base plate at the bottom. The roof. So here you've got roof sheets, whatever it is that you're using, corrugated iron or Colorbond, or if it's not roof sheets, it's tiles, whatever you're using. Flat and skillion, you've got the conventional framing, all the rafters. The ceiling, this is your bottom ceiling from inside. People often get mixed up between ceilings and roofs, I've found. So the ceiling is this, when you're inside and you look up, that's your ceiling. The roof is on the outside, that's your roof. The trusses, there you've got trusses, which there you can see where they are, the roof tiles. So you've got rafters going up. A rafter is going up that way, and then you've got a truss that goes in there. So again, just a different name for a different piece of timber in a certain location going a certain way. So just learn those terms, so when someone says, oh, we're going to do this with a truss or this with a noggin or whatever, you know what they're talking about. Roof styles. So you've got the roof corner over here. You've got the battens. So these are battens that go on that you will basically lay your it's basically a frame, but it's a piece of timber, roof batten they call it, and that's what your tile will be hooked onto. Top plates, again, I'm not going to go through all this, you can read, but you can see it's self-explanatory. These are just props, underpinning struts that are needed to hold up particular areas. So they're just the terms that are used. This is maybe over here, you've got another bearer going across on the outside. And a soffit. Yeah, a soffit lining is something they sometimes talk about and you don't know what it is, almost where basically the eave is over there and the wall stud that's going to support the eave. So, and another thing, eaves are basically this area from the wall, how far it goes out to the edge of your gutters and how far they come down in the roof. In a lot of the bulk built homes, they're just doing away with eaves now. It's much cheaper to just not put anything here. The gutters just end over here, so you have no eave whatsoever. But really, eaves are critical. They are critical to everything. They help in so many ways, but basically you need to do the calculations, which are actually quite simple. Not you, but there are specialists that do it, where they will say, right, in the north, they will put out the eave a particular length so that the middle of summer hot sun will basically not touch your building envelope. It won't touch the walls. In fact, you can stand out there at 1 in the afternoon, the middle of summer, and you'll see the shadow line will just come right to your door, but it won't touch the door or the walls. That's what you want in summer. And then when the sun is lower in the sky, when it's cooler and in winter, that sun can come right in, because that's when you want it desperately. So those eaves are critical. It also protects the building from rain. You'll often find rain comes in all different angles, but if you've got a nice hat on top of your house, they call it the hat, these eaves. You've got a nice broad-rimmed hat or eaves, you'll find that it protects the walls from all that wind-driven rain as well, and we're trying to keep it dry. So the key is to stop the sun and the rain from hitting that envelope. Those are the elements to protect you. Instead of trying to desperately have all sorts of layers to protect you and the most expensive glazing and big wall cavities and so on with all sorts of stuff in, if you actually stop the sun from hitting that glass, it will be more effective than trying to get the biggest double glazing on earth and having the sun hit that glass. If it doesn't hit that glass, that glazing is going to work so much better. And the same with the rain driven on the envelope. So just keep that in mind. Please, always eaves. Always have eaves. So these are just the different roof types. There's gable hipped at the end, stepped gable, skillion roofs. This is a very popular roof now. It's popular because you can get a very large surface area for solar panels. So if they put it up onto the north, there are, all sorts of condensation issues you have to be very careful of when it comes to the roof styles, particularly in temperate climates where there's big temperature changes overnight. But there are also low-pitched roofs, butterfly roofs into the middle. I've seen a lot of these ones, and I get very nervous about this design. As soon as it starts going towards the middle of the house and not the edge, I think it's asking for disaster. You need to know that water's just going away from the house, away from your home. The gutters are nice and big. The stormwater is nice and big. And it's just away. None of this I want to hide my appliance and have it all in the middle and hope that one downpipe holds up. Because if one downpipe gives way at some time, what a disaster to try and get into that middle of the house and fix all that up. So yeah, the roof design is very, very important. But I personally do quite like the skillion design, as long as you get all the insulation right and cope with any condensation, particularly if it's colour bonded metal. I do like that design. Inside a room, so again, this is what we're talking about, is an architrave, just that bit around the doors and the windows. The skirting is that bit by the floor and the wall, and the cornice is that bit by the ceiling and the wall. And then the older homes, they had picture rails where you could hang your pictures on. I think look pretty ugly, but they don't do it as much these days. It's more an old thing, but that's internal corner is self-explanatory, just a corner. And that is the end of the building envelope.